Section 6-1. What is a system of linear equations in two variables? I first want to talk with you about a linear equation. I want to remind you that a linear equation is an equation that can be written in the form of y equals mx plus b. So let's look at some examples of a linear equation. Y equals to 3x plus 4 is an example of a linear equation. A linear equation first must have an equal sign. You can have both an x and a y. You can have two variables. Both of these variables must be raised to the first power. If the variables are not raised to the first power, it is not a linear equation. This is an example of a linear equation. Y equals to 3. You can have just a y and just an x. But again, the variables have to be raised to the first power. You can have x equals to a number. That is a linear equation. You can also have y equals to 2x and not have the b. That could also be a linear equation. This is y equals mx. The b actually would be plus 0. So these are examples of linear equations. They can be written in different forms. I could have a linear equation in this form, 2x plus 3y equals to 4. That's also a linear equation. You have both an x and a y, both to the first power, and I actually could solve this linear equation for y. I could solve it for a y equals mx plus b form. So these are examples of linear equations. So I want us to first begin looking at this key concept. One pencil and one marker cost $1.50. Two pencils and one marker cost $2. So what are the cost of one pencil and the cost of one marker? So we're going to set up a system of linear equations to represent this problem. So let's take down a definition. A system of linear equations is two or more linear equations with the same two variables that are solved simultaneously. So a system of linear equations is two or more linear equations. So let's look at the first sentence. One pencil and one marker cost $1.50. All right, we have a drawing here. One pencil plus one marker cost $1.50. So that's one pencil plus one marker equals to $1.50. So that's how you take this sentence and draw the diagram. Taking the next sentence, two pencils and one marker cost $2. So let's look at the diagram. Two pencils plus one marker cost $2. So you see I have drawn the diagram. Two pencils plus one marker equals or costs $2. Now, look at these equations. This is your equation. This is your equation that represents the diagram. We're going to let P stand for pencils. And we're going to let M represent markers. M is going to represent markers. So, one pencil plus one marker equals $1.50. We can just put 1.5. Looking at this diagram here, we have two pencils plus one marker equals to $2 or just 2. So here I have my two equations that I have formed from the problem. The solution of a system of linear equation is any ordered pair, x, y, that is a solution of every equation in the system. So, the solution will be where these two lines touch. If we were graphing them, it would be where the two lines touch. Now, whether you've got a p and an m or whether you have an x and a y, they're both still linear equations. You don't have to use just an x and a y. You see here we have a linear equation with p and m. But the solution of a system of linear equations is any ordered pair, x, y, that is the solution of every system or every equation in the system. So, if we were to solve this, the solution of the system is 0.5, comma 1, the value for the variables p and m that makes both equations true. So this is a point. This is a point. This is where the two lines meet. So this is the solution of the system. Now, the way you check to see that this is a solution of the system, you take the two equations, p plus m equals 1.5, and you take the other equation, 2p plus m equals to 2, and you plug these in. So if you have the point 0.51 as your solution, this is p and this is m. So plugging them in to p, you plug in 0.5 into p plus plug in m as 1. When you add these together, do you get 1.5? If the left side equals the right side, that means that this point satisfies this equation. Also plugging it into this equation, 2 times p, well that's 2 times 0.5, plus m is 1. Well 2 times 0.5 plus 1 does give you 2. So when the left side equals the right side, it does check out. This point is a solution of this line. So since the left side and the right side are equal in both equations, this confirms that this point is a solution to this system of equations. So the solution of a system of linear equation is the point of intersection of the graphs of the lines defined by the equation. So let's look at these two lines graphed. Here you have the first line, p plus m equals to 1.5. Here you have the second line. These are the two lines graphed. Where do these two lines touch? They touch when x is 0.5, which is a half, and when y is 1. So here is your point of intersection, the 0.5, comma 1. So this is the solution of this system of equations.